before for the first company, I'm picking up to this point, just copy, okay, just paste it here. Then for this company, okay, I'm taking up to 2007, so you see consistency. Okay, assume I have 3 companies. Okay, so using 3, though I've asked you to use 2. Okay, so this is all before, up to 2007, all before on one side. I don't care whether it is this company or that company, it's all on one side. When I come to the after, I want to leave 2008 out, and I want to start from 2009 down to, so I need 4. 1, 2, 3, 4. So I'm copying up to that one. Okay, so put it here after. And then from 2009 for this one. 4. So I copy, and then I paste it here. Come this way, 2009, after, copy, and then I paste it. Now remember, this is for just one ratio. This is for only ROC. I would have done the graph. Now I want to test whether it made a significant impact. If you see before, let's say before crisis, like I say, ROCE before crisis. Okay. ROCE after crisis. Okay, to do a t-test on this one, very simple. All you need to do is just go to data, and this one, because this is Malcolm's login, it is not, you can see Malcolm Benson. He hasn't used the data analysis tab, so you need to bring it. And I showed you the last time how to bring it, right? Yes. So if you are not here, just file. If you're 2007, there's a small circle here, okay, and then you come to our options, and this is where we saw some people did not buy. So add in, and then you need for analysis to pack. Okay, click go, and then make sure this is selected. The first one selected, then okay. Can you see, or do you want to put up some of the lines?
Yeah.
Which one? Is that one? Can you? Yeah, I think it's better.
Much better.
Yeah, thanks. Okay, so I click OK. I'm waiting for this one. Okay, so this is the data analysis tab now. So all I need now is I want to do a t-test. So the t-test I want to do, because these companies are in the same country, or where are they? Which companies are they?
United Kingdom.
They are all in the UK.
Yeah.
Yeah, so I'm looking for what you call t-test assuming equal variance. Okay? If the companies are in different jurisdictions, you say t-test of unequal variance. If one company is too big than the other, t-test of unequal variance. Somebody sent me an email, said, David, can we use this, that? And I said, we can do it, but we have to do a lot of statistics. Okay? So if the sizes are similar, location are almost the same, t-test of equal variance. So you click on that, then okay. Now it is asking you, what do you want to compare? Which 2 variables do you want to compare? So variable 1, I click on that, and I select from here to there. Okay, look at where I selected from. I included the headings. We call that labels. Okay. Then variable 2, this set of labels as well. So I've got 42 now. Note that your last two digits should always be the same. If they are not the same, you click it to give you error. That is the selection of the variable. Now, I'm going to go into a bit into statistics now. Hypothesize mean difference. What you want to say is, and I used this analogy the last time, I said that if you go to the court, you are not guilty until proven guilty. Are you aware?
Yeah.
When you start the court case, the judge will not see you as guilty until you have been proven to be guilty. We call that the null hypothesis. Okay? When you're doing a null hypothesis, like you've done in your research methods, the financial crisis did not make an impact. Okay? So that is, then all that you're trying to say is before crisis and after crisis, the value should be what? The same. So if the value before crisis, let's say if it is 10, and the value after crisis should also be 10, then there's no difference. It's 0. So hypothesize mean difference. You put 0 here. Meaning that before crisis and after crisis, no difference. Then the computer will tell you whether there was a difference or there was no difference. The judge will sit down and the police will say that the evidence gathered, all this that I think that David should be guilty, okay, and my I'll be the defendant, right? I'll try to, like what is happening in Oscar Pistorius murder case, right? And the girlfriend. Are you following that? Okay, he has not been charged with murder, but he's been charged with what? Manslaughter, meaning unintentional killing. And that is what they call culpable homicide. Anyway, financial crisis, you don't just go straight away that because the graphs are going up and down, it made an impact. You didn't take every bank in the UK for you to come to that conclusion. The Scottish people, when it was announced that the no vote was 52%, you did what we call statistical inference. Now, if that figure should stand, the computer should tell us. It will come out in the statistics. How will you know? So we put 0 here. Make sure this is ticked at 0. Okay, labels. And then alpha of 0.05. So this is alpha of 0.05 means alpha of 5%. You'll be hearing people say, oh, a margin of error. What this means is this. How confident are you that what you're doing is right? For that confidence interval. So you say that I'm 95% sure that the financial crisis did not make an impact. Or let's put it this way, I'm 95% confident that the financial crisis would have caused a stir. Let me put it that way. Now, if I do the analysis and alpha, or we say that my p-value, my probability value, is less than 5%, it means that my confidence has gone up, that an impact has taken place. I think you need to see the results before you do. Okay, this is 0.05 by default. That's what we do in statistics. If it goes up, thank God. But if it comes down, we're in trouble. So watch this. This is, just click OK. And this is what is going to give you a headache all your life. According to these results, the financial crisis made an impact. How? How do I see it? All that you're trying to say is this. Before crisis, this was the figure. On the average, I got 36 point that is the mean, okay? The average. All these figures put together. And after crisis, I got a figure of 17 point. Or you are trying to test it. Are these two figures different? Yes, with your eyes, you say they are different. Okay? But statistically, They may not be different, they may be the same. How will I say that? Descriptively, the graphs, yes, they are different with I. But can 2 banks or can 3 banks represent all the banks? Can 800 people represent the entire Scottish people? That's what you're saying. Well, what these 800 people say, is this the same as what the entire population of Scotland will say? That is what you're doing. Is that figure different from that figure? That is what you're testing. Now, how will you know whether they are different? You can either use from here. 1, 2, 3, 4, 5. All of them will say the same thing, depending on how you say it. So I want to take the one that you need, okay? I can use this one, T. If T is greater than 1.96, can you write that one down? This is if T is greater than 1.96, plus or minus 1.96.
Standard deviation in the normal distribution.
Thank you.
Yeah.
So if T is greater than plus or minus, how do you put plus or minus on this one? 1.96. You need to put plus or minus in front. You know what plus or minus? If T is more than this, you can check this one. This is 4.78. If T is greater than that, okay, according to normal distribution, we say that there's an impact. It's unlikely that this figure and this figure will ever be the same. No. If you don't understand this one, then you can come and check this one. P1 tail. Who can tell me the figure here? What is this figure? Tell me, I just need one figure.
Where?
This one. What is that figure there? That's one figure.
0.0004.
So that figure there is what? 0, 0, 0, 0, just 0. You don't see 0? What is E minus? It means that this is going this way. You remember you did standard form in your primary school? Okay, so this is, put how many zeros in front of this? 4 zeros. 4, because you are shifting to include this 4. So you have 4 zeros in front of the 4. So what this means is almost 0, right? If you take this 0 from 100, or you say this is 0%, it means that you are saying that you are no more 95% sure, but you are 100% sure that the thing made an impact. Let me come again. This figure here is 0. Assuming this figure here is 2, right? Let's say 2. It means that, you see, you are 95% from the beginning. That's the way you did the analysis. Alpha 0.05 means what? 5%. What is left is 95%. Okay. Anytime this figure, if it's less than 5%, then it's an impact. If it is more than 5%, then it means it's not impact. So look at this. This is 0. 0 here means that you are not 100% sure. But let's start it this way. Let me give you a very simple example, the one I always use. I'm taking a patient to the theater, and on my way, I say that, what is your name, darling? Sri. Okay. And I say you are Sylvia, right? I'm taking Sylvia to the theater, and then on my way, I'm the doctor. I'm a doctor as well, right? Medical. And I say, Sylvia, I am 95% sure you're going to survive this operation. What will you be thinking of? The 5% chances of death, right? Though I've given you 95. It's human that you think of this 5% chances of death. In the middle of the operation, I said, darling, I said 95 from the beginning. I think I'm now 92%. I think you will just die. Because even the 5% chances, you were thinking of it. Now I have given you more chances of what? Death. It means my confidence has gone down. What about if in the middle of the operation I said, Sylvia, I said 95 from the beginning, but now I'm 96% sure. I have given you what? Little chances of death. My confidence is what? Going up. What about if I say, I'm now 99% sure you survive? It means just one. Though you still think of it, I don't think you think of it when it was, you not give it that same thinking like when it was 5%. You get that? The same thing is happening here. If this one is 0, if this one is, let's say, 2, right? Then it means that my confidence has gone to what? 98%. If this one is 3, it means my confidence has gone to what? 97%. Now it is 0. It means I am sure that these two figures are not the same. But remember, this one is called P1 tail. And we have P2 tail. One tail means that you are one-sided. Example, I meet you and I say, I am older than you. That is one tail. I'm standing at one side and I'm saying I'm older than you. But if I meet you and I say our ages are not the same, you can either be older than me or I can be older than you. That is two tail. So here, I think most of you will have to do a one tail. Say that the financial crisis had a negative impact. If you do that, you can see that this figure, this is 36, and that is 17. It's because of the financial crisis. That is why this figure is coming down. Okay, I don't want you to be talking too much of the numbers. I just want you to tell me that whether it's made an impact or it does not make an impact. We are not doing statistics in this class. We are applying statistics. So when you talk of the descriptive, you just say that further investigation revealed that the financial crisis made significant, you have to use that word, significant impact on returns on shareholders' funds. Okay? Now, if this figure is not significant, if this one, it's like, let's say, if this is 6%, if this is 6, it means it hasn't made an impact at the 95% level. So if this is 6%, you say that although the descriptive statistics above, although the descriptive analysis above shows some slight changes, you say that it was not statistically significant. I don't want you to talk too much of the numbers and then say that, see Appendix A. When I go there, I will understand it myself. All I need you to tell me is, did it make an impact or it did not make an impact? How will you know? Say, go to Appendix A. You're looking for this figure. Okay? Check this one. Or if you understand this one, is this figure more than 1.96 or less than 1.96? If that figure, these two, they'll be speaking the same language anyway. If you even check two tail, look at this. Where's two tail? This one? This is also almost 0. Okay? So just choose one of them. Anyway, when you have your spreadsheet and we play with the game, you understand it, okay? The thing is, if I were to be teaching BA1 students who are in corporate finance now, assuming that they have come to corporate finance, they will apply this straight away because I teach this one in BA1. But let's take it like it's a long time you studied it or you've never studied this before. It's not, you don't have to worry yourself trying to understand every single number there, or you're using this one to test it. Are there differences in the figures? That's all you do. Okay? So, if you are confused, whether it made an impact or not, you do your results, do your analysis, show it to me, and I'll assist you here. Okay? Now, the next one I want to do, so you see, when you do this ROC, the next one you do for, let's say, RO, you have return on shareholders. Okay, what I did was return on shareholders funds. So this one will be on ROC. I think the one I just did was on RO. It was supposed to be this one. I made a return on shareholders' funds instead. Okay, and I used 3 companies. Right. That is for the t-tests. Okay. Remember, you would have done your graphs and other things from the beginning. That is why you saw that this guy did not spend too much time trying to talk about tables related to t-tests. He just directed me that I should go to the appendix and find out. Okay. I'll find the way. Right. Can we do, the next one we want to do is we have to do a regression. Now, if you go to page 3 where I have P1 is equal to all those stuff, P2 is equal to, when you're doing a regression, so we take one at a time. Assume we take this first profitability ratio, I'm taking from this point. Okay, using 3 companies. Let me copy that. I hope you know that when you just hit enter, it will paste. Okay. This is my first profitability ratio, and that was return on investment or return on equity or return on shareholders' funds. Okay. This is my dependent variable. Okay. My yearly ratios I have are these. I'm going to select all of that down to this one. So all is free. Okay. And I paste them here. That is gearing. The next one is interest cover. And the last one is what you call liquidity ratio. Liquidity ratio is not liquidity ratio is liquidity. Please. Okay, let's assume I have these 2. Okay. And all I need is I need to do a regression. So simple. Data analysis is searching for regression. Where is it? That one? Okay, regression. Regression is to help you to come up with models to predict from the unknown. Okay, so I click on that. So the same thing, but this time the computer is asking me which one is my dependent variable. You remember last time I told you that the dependent variable is denoted by Y. Okay, so look at it. This is the dependent variable. If you are using Stata, you know Stata? Or if you are using SPSS and so on, it will write dependent variable straight away. But Excel will put Y. Okay, click on that. My dependent variable, does the profitability depend on the capital structure? So click on, so your independent variable comes in here, your X's. So this one, so X1, X2, so I'm taking 1, 2 together. If I have 3, I pick the 3 together. I have 4, I'll pick all of them together. Okay, so I moved it down, so it's 2 of them to that point. And all I need is, I need my labels again. What is your level of confidence? 95%, that's the way we do it, right? And you don't need line fit plots, but you can just click OK. Fantastic. So this is the results we have. Okay. Wow. Okay. I understand every single number there. I don't think you do. Do you? I can see that. Yes. This figure here, this is a p-value. It's got an impact on the profitability of the firm. But this one hasn't got. This gearing calculation hasn't got. But I think my next class, I don't have to teach you any topic, then I think I need to teach you the interpretation of these things. I will be very, very glad if you could come to the class with your spreadsheet. If you have your data like this, then everybody does the analysis. This one alone will tell us the correlation, multiple correlation, R squared. How much of profitability can be explained by these two factors? 54%. It means that the remaining are other factors that you did not include in the regression. Okay? But the key one I'm looking for is this one. You see, you can use the T statistic, this one. See, all of this, from this point to that point, they all say the same thing. So I'll spend a bit of my life next week explaining things that I'm not supposed to explain. Remember, we still have one serious thing to do called event analysis. And that will kill us. I know you don't understand. Your faces have changed. Going forward, I need